All right, welcome. Let's look at the first two pages of our final exam review. Here we go. So the first thing that I wanted to look at is question number one, of course. And I was kind of thinking about this problem that many of you have probably been in that situation where there's four people and there's a pizza and there's 12 slices, and you're like, okay, so each of us gets three, because there's four people with 12 slices. Well, the reality is, I think we use this idea of proportional reasoning all the time. And so I know that many people are going to look at this problem and immediately make that determination that we should just cross multiply and go. And that's not a terrible idea to do, but it's not actually the most efficient way to solve this problem, because the reality is most of you probably don't have memorized what 9 times 12 is, but it's 108. And if you divided both sides by 54, you get 2. Now, what I mean that that's not the most efficient way is you could see right here, 54 has a relationship with 9. 9 times 6 is 54, right? So 54 divided by 6 is 9. 12 divided by 6 is 2. We could have just looked at it and seen the number 2. Now, in that same way, we have that option right up here. I could see that 5 times 7 is 35. So if you divide by 7, this happens. So x plus 7 has to be whatever 91 divided by 7 is, which is 13, and we get 6. Now, again, like I said, if that's not the kind of thing that you recognize readily, it's okay. We can cross multiply and call it 35x plus. Now, of course, I don't have in my head what 35 times 7 is, so I got to grab a calculator because, well, that's just not something I do that much. 245. I guess I could think it through, but and then 5 times that'd be 45, so 455. And then do a little let's see, 455 minus 245, and then divide that by 35, and we're going to get the same answer, right? We got x equals 6, and I should probably finish writing that out more thoroughly. 455 minus 245 is 210, and then we're going to divide both sides. But see, just using just proportional reasoning instead of hey, always cross multiply. Now, that being stated, this next problem right here is a little bit harder for me to see a quick solution. And so this is the one that I did just say, oh, well, I'm going to go ahead and cross multiply. 5x, 5 times x, and 5 times 30 times 7, 3 times x, and 3 times 17. So we're going to go ahead and subtract our x's so we can combine our like terms. We're going to add 35 to both sides and 86. And a little quick division, we get 43. Now, for me, what I'd like to do is I'd like to just double check that I actually didn't make a silly mistake, right? So 43 minus 7 is 36. So let's see, I got 36. And 43 plus 17 is 60. Now, let's again use that proportional reasoning we talked about. So when I look at those values, the first thing that I notice is that 3 has to be multiplied by exactly 12 to get 36. Is that true for this? Is 5 times 12 also 60? And that answer is 100% yes. So I know we now did okay. Now for number two, really there's nothing fancy about this. We're just going to go ahead and do a little distributive property. We're going to do a little combination of like terms and see what happens. So I've got 5x and negative 6 times 4 and negative 6 times negative 2 would be a positive 12. That's the place where we're probably going to see the majority of the errors is the negative times the negative here. I guess we can put these two together and call that 17x's. And things are kind of wrapping up pretty quickly here. Add 24 to both sides, and so we get 17x equals 51, and we got x equals 3. Now, I actually really do like to check my answers when I'm done with a problem, just to make sure, especially when you're talking about a test where every question on a test has the value of a traditional homework assignment. Like every single question has that much weight on your grade. So 3 times 5, of course, is 15. So I got that. Minus 6 times, let's see, 4 minus and 2 times 3 is 6. And I'm hoping that that answer is going to be 27. So you see how that was not very hard to check my answer. I don't think I had a headache after I did it. Okay, moving along. Okay, number 3, we have a variety of ways of looking at this thing. And so, like I said, I'm probably going to go a little slower on this than you would have to. But again, the idea here is because I've got these two triangles right here, and the assumption is that the person is standing straight up and down. The tree is straight up and down. So they're both at 90 degrees to the earth. And then we've also got this angle right here. I've got two triangles, so triangle number 1 and triangle number 2 are actually similar by AA. Now, this is not a proof question where you have to justify yourself, but it's important to understand why that actually works. And what we know is if triangles are similar, they have the same angles, but that also means they have the proportional sides. So we can set up the same kind of proportion that we had in number 1 up here. So we could say that the height over the base is equal to the height over the base. That's kind of the concept that we're working on here. So I could say 6 over 8 is the same thing as the height of the tree over 20, right? Now that puts us in a position where we can, again, cross multiply, and 120 equals 8x. And so, of course, 120 divided by 8 is 15. So we found out that this tree is 15 feet tall. Now, like I said, I'm going to go a little slower, but what I decided to do in my head when I saw this problem is like, fine, I'm going to go ahead and scoot a little child over here that's only 3 feet tall. Therefore, proportional reasoning, if I divide this by 2, I could divide this one by 2 and say 3 versus 4, right? Well, 3 versus 4, what you'll notice now I have a nice proportionality. If this is 4, the 20 is 5 times as big, right? Which means from the little person to its shadow, I guess you could say, or the base, 4 times the base is this, so 3 times 5, the same thing, 5 would be 15. So that's kind of the way I actually did it. I did not do this right here. I immediately saw that I could reduce 6 and 8 into a smaller triangle that would make it easier for me to see. Now, we have this separate question here, number 4, that says the 6-foot tall man right here is casting an 8-foot long shadow. And it says the tree is casting a 20-foot long shadow. Well, what you're going to see is that's exactly the same information as the one above. But I do think it is worthy of note that to understand that when you take a look at the rays of the sun coming down, because the sun is so far away, the rays of the sun as they hit the earth are parallel. And so the reality is, even though you don't have that, you could actually think about this as being corresponding angles. You know, parallel lines, this would be our transversal. That allows you to do this. So I'm not going to write this out because my penmanship isn't the greatest, but what is the same about these problems is virtually everything. Almost everything is the same. You have exactly the same proportions. You've got 6 is to 8 as x is to 20. You've got all of this stuff set up exactly the same. Um, what is different is that in this particular situation, the triangles aren't overlapping. They're just separate. So there's very, very little that is different about those two stories. Okay, so we'll finish up page 2 and then we'll be done. Okay, so page number 2. So what we have right now is this idea of these two intersecting lines. And so keep in mind that angle 1 and 2 are adjacent. They're side by side. They also together, if you go like this, you'll notice they form a line. So we're going to call that a linear pair. So remember, a linear pair also means that those angles are supplementary. So remember, linear pair and supplementary kind of go hand in hand but not all supplementary angles are linear pairs. This is a specific situation when they come together. This is a stronger word though, isn't it? So that means I'm going to go ahead and take these two angles that I have been given, and I'm going to combine them together to say that they have a sum of 180 degrees. And so a little bit of combination of like terms. I've got 8x's, 21 minus 5 is 16. We're going to go ahead and subtract 16 from both sides, which is going to be what, 164. And then we're going to divide both sides by 8. And we got 20 and a half. Now, like I said, I personally really like to check my answers, especially if I don't get whole number values, because it makes me wonder, did I make a mistake? Should it have been something that wasn't perfect? You know, because math teachers usually make things perfect for their students because they don't want the students to make silly mistakes. So I did 3 times my 20 and a half minus 5. So I found out that my measure of angle 1 was 56 and a half degrees. That's a curious result. Well, 5 times 20 and a half plus 21 is 123 and a half. And if you actually check that out, those do in fact add up to 180 as they were supposed to. So it appears that we were not in error by getting that value. Now, the next one is the idea of vertical angles. Anytime you have two lines that intersect, the ones that are across from each other are called vertical. And that actually means that those angles are going to be congruent, which means they're going to be exactly the same shape and the same size. So I'm going to go ahead and take these two values and set them equal to each other. So as before, I need to start combining my like terms, but here they were on the same side together and I could add them, but here they're on opposite sides. So I'm going to have to work a little teeny bit harder. And that means I'm going to add 25 to both sides, right? And then finally, we're going to divide both sides by 3, and I got x equals 16. Like I said, I always like to check my answer. 7/16 minus 25. Oops, 7 times 16 minus 25. Looks like 87 degrees here. Now, that picture might be a little deceptive because you might think, oh my gosh, that looks like an obtuse angle. Looks like it to me. But remember, we tried really hard not to always believe what the picture looks like. We just try to make sure that the math proceeds correctly. And in fact, you can see I got 87 both times. So it looks like we did okay. All right, moving on. If these two lines are parallel, so that's parallel lines. This is our what we call our transversal. The same thing is going to happen here. I have parallel lines cut by a transversal. Remember, transversal is a line that cuts two other lines. It doesn't have to be parallel. Sometimes you can have transversals like this, where the two lines are not parallel, but that's okay. But when we do this, you have same side interiors angles, and in this case, they happen to be supplementary. Now, it is not okay for me to call them a linear pair, though, because linear pairs have to be side by side, and these are actually not adjacent angles. They're not even sharing the same lines, plural. So, but I can certainly add them together. Angle 1 plus angle 2 equals 180. These x's are on the same side, so I can just do a simple combination of like terms. Subtracting 60 from both sides is pretty simple. And then divide, and I got 20. Again, I know that this is going to bother some of you guys to keep checking my answer, but 4 times 20 is 80, and 80 minus 15 is 65. And up here, 20 times 2 plus 75 is 115. And yet again, we see this weird little thing where it looks like the picture might be a little deceptive. That looks like an acute angle and an obtuse angle, but they do in fact add up to 180 like it was supposed to. And what that really means is we found a nice diagram to do it, but we made sure that it came out nice, but we didn't necessarily try to make sure that the picture was a perfect representation. Okay. Now here we have alternate interior angles. Now, again, alternate interior angles are not always the same. Like here, these would be very, very different angles if the lines aren't parallel. But since they are parallel, that's going to make the angles congruent. So there we go. And we're off to the races again. But again, like what happened earlier, the x's are on opposite sides from each other. So we're going to have to go ahead and move the 2x across or the 5x across. I personally like to move the 2x across because I like my variable portion to be positive. I just, that's how I was always trained, so I'm careful to do so. And then a little division gives me 27. So let's see, did we do okay? 527s minus 2, 133. Let's see, 227s plus 79. That looks like 133. It looks like we did very well. So last, number 10, and that'll be the end of our first video for the first 2 pages. It's given in my information that AD is congruent to CB. Now, again, I've said in my classes all the time, do not let this diagram go around naked. Nobody feels comfortable around everybody else in that state. So make sure you put clothes on it. Put that information on that diagram. So AD matches BC. I got the first one. And this tells me to trace angle ADB. ADB, that's right here. ADB, as I trace that, I'm tracing this angle right here. And it says it's the angle of CBD. That's this angle right here. So in the given information, I was given one side and one angle, but I also have one more piece. Side DB is the same as side DB. In fact, those are shared sides. And so that means I have a side, an angle, and a side. And depending on how you or your teacher did, some people just say SAS, but you're really supposed to say SAS congruency. And this is a postulate that we learned. Our book calls it a theorem, but it's really a postulate. So we have to make sure that we are careful about that. But a hint is that we already told you a good way to say it. ADB matches CBD. And the order of these letters completely matters, right? A corresponds to C, D corresponds to B, and B corresponds to D. Now that is kind of interesting because notice that DB is not the same as DB. It's that DB is the same as BD. Is that if you look at something and then you flip it over, you're looking at the same length. Okay? All right. Well, thank you for joining me for the first 2 pages of your review. And I'll be back for another one soon. See you back in class. Bye-bye.